Alright, hello once again. This is Jeff Scott of Rankin Technical College. I've been going through a series of video presentations for the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD1100 C# Programming Fundamentals class. These video presentations have been based on the book for the class, which, as you can see, is Muroc C# 2015. The book has 26 chapters, and so far I've done all Section 1, the 3 chapters, an intro to Visual Studio, all of the 8 chapters for Section 2 on the C# Language Essentials, all of the 5 chapters in Section 3 on Object-Oriented Programming, and I'm in the first chapter, Chapter 17, on Database Programming. So, when I left off last time, before we even go into looking at what's in the book, I showed this example that's right here. And I said, if you've got a table like this with an ID, a department, hours, rate, first name, last name, etc. All right, well, one thing about this, just so you know, okay, I've got here an employee department, all right, and probably it would be like a department name. The problem is, if I've got thousands of people working at the company, which, you know, is not inconceivable. Some people might spell this accounting, some might say ACCTING, you know, whatever. But there might be different ways that it goes into a database. So what I want to show you is this. Probably we would end up taking something that looked like this, and at a bare minimum, I would create a second table here. And this would have an employee department ID followed by an employee department name. All right, and I'll show you why in just a second, but let's change this one here to ID, and then let's talk about why we'd want to do this. All right, so imagine I had 5 different departments. Again, I'm trying to keep this fairly simple, I hope. But, so I said here, Department 1 was shipping. Oops. Department 2 was accounting. All right, Department 3 was receiving. Department 4, let's say, is marketing, and Department 5 will make information technology. All right. Now, what's going to happen is the word accounting should only be in here once. So this is going to change. All right. I've added the employee ID in here and change that from name. So this will now say where emp department ID, instead of saying it like this, we'll say equals, come on, two. Now, it may not look like we've done a whole heck of a lot, but that's a big change. All right, so I now have this table right here, and I have this table right here. Now, what if my boss says, you know, that's really good, Jeff, but what I need is I need for you to come up and give me a list of all employee first name, last names, department IDs, and department name. In fact, let's just even say that we don't even need the department ID. All right, I'm going to show you 2 ways of doing this. First, I'm going to come in here and I'm going to say select emp first name, emp last name, emp department name. All right, Now, what I want to select that from are two different tables. From, and we're going to say this is called employees here. And we're going to say that this is called departments. All right, we'll just move this over. So we're going to select this from employees, and we're going to also give this what's called, or what I like to call it, an alias. E, departments, D. Now I'm going to show you two ways of doing this. The first way I'm going to show you is what's considered the old-fashioned way, but this is the way I was taught to do it. And that was to say where E dot emp department ID equals D dot emp department ID. Now think about what we're doing. We're telling the system to give us all the first names that are in here, all the last names that are in here, and all of the department names, but we're doing what's called a join on these two tables. So we're combining the information from the two tables, and in order to do that, that should be a D. In order to do this, all right, I'm doing what's called a join on the two tables. And that is saying I've got to have a field that is common to both tables. Well, there's emp department ID there and there. So I'm able to do that. Now, the other way of doing this, and I believe this is the way our book is going to mention it here, inner join on. All right, so I'm going to just copy this. And this will say again, select emp first name, emp last name, emp department name, all right, from the first table. And then I'm going to come in here and say inner join, all right, departments, D, on. I think that's the right syntax. See if they have an example in here. Select this, from this. All right, it's inner join on. All right. So yeah, I do have inner join. So the idea behind these two things is the same. So in other words, I should get the same results here that I get here. Now, what you will find if you read this is most of the people who look at this will come in and they will say, you should do it this way. It's the newer fandangled way, and it supposedly at least runs faster than doing it this way. I particularly like this way. I guess I'm biased because that's the way I learned how to do it, but not just that. To me, it makes more sense. Now, you should do it the way you should do it. That might sound stupid, but what I'm saying is you should do it in the way that's easiest for you. But you'll probably today, more often than not, see it like this. So, jumping back into the textbook, and I'm already 10 minutes in and I haven't gone through anything. But let's just go through some of this stuff that's in here, or as much as we can. This is the syntax for joining two tables. All right, and here's an example. Now, not only are they joining two tables, but they're putting a where clause in here, which means we only want them where the invoice ID is 46. So notice what we're doing here. We're saying that what we want is from the line items table. We want the invoice ID, the product code, And then from the products table, we want the description. And then from the invoice line items table again, we want the unit price and the quantity. So it looks like what we're looking for is everything that's involved in invoice ID 46. And to do that, we had to combine information from two different tables. And when you do a join like this, you're not limited to just two tables. If you've got 10 tables and the only way that you can get information is to combine information from all 10 of those tables, you can do that. Now, I wanted to go back and just show you this. This was the database that the authors showed in the book. So let's suppose that, this is just going to be way out there, but what we wanted was for each order, we wanted the customer name, the customer ID, let's just say the invoice date, the product total, the state the customer was from, the product description, and the unit price. We could combine that information from all 5 of these tables. You'll notice I said before this table here is kind of out on an island, meaning that there is no place to really go and grab that information. There's no way to combine this information with the other stuff. Okay? All right. So that was quick, but as it says, how to join data from 2 or more tables, you need a field in common, and then you do what's called an inner join. Notice it says with an inner join, it only returns rows from both tables if their columns match. All right? It's also called an equijoin. You can also do checks where the rows don't match. All right? It's a little bit more other stuff to talk about, but let's just keep it where we are right now. Here's an insert statement. What we're doing here is we're telling the system what we want to do is insert into the products table. And let's look at products. There's products. It has 1, 2, 3, 4 fields. A product code, a description, a unit price, and an ordered quantity. And we're saying here the product code will be CS15. The description will be Murox C# 2015. The unit price will be $56.50, and the quantity on hand will be 3,000. But the insert allows us to add a new record into the database, which is exactly what we're doing right there. An update allows us to make changes to an existing record that's in the database. Now, when you do an update, virtually 100% of the time you'll want to put a where clause in here. If we did not put a where clause in here, if we said to update the products table, and if all we said was set unit price equal 54, we did not have that where clause, that would set the unit price of everything in products to 54, which almost never is going to be what you want. So again, when you do either an update or a delete, you virtually 100% of the time want to put a where clause in. So here's the delete. In fact, if right here we said delete from customers, we didn't have a where clause, it would remove every record from the table. Again, probably not what you'd want to have happen. All right, I'm going to stop right here. Even though it's a little bit early, we're at 14 minutes, but come back and do one last lecture on some of the special things that we have here for working with databases. And I'll be back with that in just a minute.